Hey guys, welcome back to my videos. And in this video, we are going to talk about gRPC, that is Google Remote Procedure Call Technology. So you can see RESTful API architecture, which is very traditional and you might know already. So before I start, let me tell you that this video is not about discussing differences or advantages, pros and cons between RESTful APIs and gRPC. But if you are willing to do a career in backend engineering in Python, then it's important for you to know this gRPC. And we are going to learn how to implement simple gRPC program, gRPC protobuf implementation in this video. So just to give you introduction, this is how RESTful APIs looks like. Traditional RESTful APIs where client initiates request using HTTP protocol. So HTTP libraries at the client side, like in Android, iOS, or JavaScript, or any other technology like Python. So using this HTTP protocol, HTTP GET, POST, DELETE, PUT, REQUEST, client performs request to a server for specific data, and server responds to a client in the same request with that data or with some error, and that response is consumed by that client. This is how traditional RESTful APIs architecture works, right? Now, this is HTTP 1.0, and the data type or common data type which both client and server should adhere is JSON, right? So in this technology, what client and server needs to do is, if so, whatever technology client and server is running, they have to serialize their objects to JSON and vice versa, and serialize and deserialize, right? So whenever client wants to send data, they will serialize data, and when server receives data, it will deserialize those JSON object back to its business object, right? So now coming back to gRPC, what is different in gRPC? When I started reading about gRPC, I actually felt nostalgic and have used SOAP technology, which was there earlier, even before REST. So in that, so I felt like it is quite similar to that SOAP technology where you provide WSDL URL, which is definition of your interface between client and server, and based on that interface, the client server classes are automatically generated. This gRPC is doing same thing, but there are other things which gRPC offers. So first of all, let's look at what gRPC is. So gRPC is another way of initiating or performing client-server communication. And what we do is we start with one protobuf protocol, or we call it interface, where in this protobuf file, we declare what are the objects that will be exchanged between client and server. That is the business object, the type of that object. And the next we discuss is about what will be the request and what will be the response. Another thing that we declare in this protobuf is the kind of communication, because gRPC supports HTTP 2.0, it supports streaming or bidirectional communication. So what does that mean is, once the connection is established, you can exchange, client and server can exchange bidirectional data, unlike REST APIs. So if you have used socket programming in TCP, then you would know that once the socket is connected, then you can use that socket input stream, output stream bidirectional, right? So something similar here in gRPC, once the connection is established. But remember that client needs to make a first request. Okay, so with that, let's start with new project. So let's start with implementation. So this is about gRPC. Now let's talk about implementation, right? So here in this example, we are going to create client and server, both client and server in Python. But in real life scenario, you can choose the languages between C#, C++, Dart, Go. So you can see all these languages gRPC supports. So any language you can choose, and you can create client and server in different languages, any language of your choice. Let's get started with the coding part. I'm going to create new project. Over here, I'm going to name it as gRPC tutorial. Yeah, I don't want main.py to be created, and 3.12 looks good. Yeah, it's creating virtual environment. All right. Here I need to paste pip install gRPC.io and gRPC.io tools. Okay, so let's wait for this installation to get finished. All right, we can start now. Now the first thing that we are going to do is create new file name. The first communication that we are going to see is unary communication, that is traditional REST kind of communication, which is very easy. You will request and you will get a response. So here I'm going to create file with extension .proto. Yeah. So now in this proto file, what I need to do is to start with syntax equal to, we are going to use proto 3 version of this protobuf. Then we need to declare package, that is unary. And now important part. So this language that you are looking, it looks like more of a, what you can see, more like Java and C++. Here we are supposed to make a call, but before that, let's declare some data structure. I'm going to declare simple message, string message, and here you need to provide some integer value. This is actually required for serialization, this data type. And this is how I have declared. So I'm going to exchange this message in request and response. So suppose this is a call. This is the RPC call. So here in input, I will declare I have message, and in return into bracket. So, or what we can do is we can simply here, I will rename this to more request payload. Okay. And here, let's say we have response payload, and inside that actually you can have anything you want. Response payload. All right. And here, don't forget to add semicolon. Okay. So this is how my protocol is going to look like. Now, what we need to do is we need to come back to terminal and we need to fire command. I need to do Python -m gRPC _tools.proto-c. Proto path is going to be this path, that is dot current directory, and the protocol unary proto, yes, file name, and Python, how we want Python out, which is going to be in same directory, and last is gRPC Python _out. So this command you can actually look at here in this documentation. Okay. So somewhere I have forgot semicolon. Yeah, here in its first row itself. Okay. So now what do we have? You can see two files are created for my service, unary pb2 gRPC. All right. I'm going to create client file first, which is unary. Let's create unary client. We have to first create server, right? We cannot start. Yeah, let's implement server first. Now, here what we need to import is first of all gRPC, and then after that we have to import this unary gRPC port unary pb2. Yes. So these two services we are going to need. Let's create one class with unary service. Here we have service, right? Unary service. Yeah, here you will see unary. It adds this R servicer, right? And now visualize this with nothing. We have implementation, right? Here. So what do we have? We have implementation, this get server message, right? So here you will see two objects, request and context. Client is passing some parameter. So here you can see this request payload, right? So this request payload has message, correct? So I can actually print here request dot message. So this is actually a request payload, right? Let me print request param. Okay. And here server is supposed to respond back, correct? So here I need to use a return keyword. So remember this return keyword. Why? Because when we are doing to bidirectional, then you will see why I'm saying this. Remember here to return this keyword return. Now we have to return, we have to form this response payload, right? Just like this. So it expects response payload. So what I'm going to do is we have this unary So here I will have request payload. Here inside that I have message equal to maybe some message here. Let's say received, parameter received. That's it. So this is about unary service. And now let's go ahead and declare. So this is the class is defined. Now what we are going to do is we are going to write main method. So here what we are going to, so far we have to start server, right? So to start server, we need gRPC dot server, and here we are going to create a thread pool, and for that we need futures package. Let's import from concurrent. Let's import future from concurrent import. So we need to pass futures dot thread pool executor. And let's say for this example, we don't need much maximum workers here. I'm going to use just 5. And then we have to specify port, insecure port also, and also need to add unary gRPC dot add handler, which is the one we created above unary service. All right, the one we created here, right? Unary service. We have to add port here. So the port, declaring port, please remember the syntax. The port number is the one we are using, 5051. So we let's start, and final is server dot wait for termination. Okay. So server will keep running and unless we terminate. Okay. So this is how our server is going to look like. Now let's come to the client part. So in client import, we need these 3 lines, and the last part is let's implement. So here what we need is we have to create client, right? So client equal to, let's create unary client, and let's create this unary client. Oriented programming in Python. So actually speaking, this is, we are just creating a wrapper. Okay. So let's say I'll pass this. What all information we need to connect client, and so for that we need some information. So let's initialize this with host name, that is localhost. So remember, just like REST API, you need IP address and port number, right? Port is 5000, right? Then we need to declare channel, gRPC insecure channel, and the first parameter is target. So we pass host, and second is okay. All right, so this is done. Channel is created, and now we create stub part, which is unary v2 gRPC dot. This is a client stub, and we pass self dot channel. So now we have subscribed to this channel, correct? This is about initialization part. Now what we need is we have to pass. What we are going to do is we need to, as per protocol, we need to get this message, right? So what I'm going to do is I'm going to create one method. I'm going to create exact same method that we are going to call here. Actually speaking, it will look like this: client dot get server message, right? And here I'm going to pass message equal to I from client. Okay, so this is how I want to pass, correct? So here let's now use this stub. So the message, let's do one thing. Let's create a request payload. How we are going to create payload is using this object request. Let's go and check. It's here, request payload. So in response, actually it should be a response payload, right? And here in request, we should have request payload. And inside these, we are going to have this message. So we have created our payload, and now we are going to use this stub self dot stub, which actually performs our method get server message request payload, correct? Here, let's catch response and print response or message. So let's try to run this and see. Okay, so we have some problem. we need some argument here in server. Yeah, we forgot to add second parameter as server. Okay, so server is started. Now let's try to run the client. Oh, my bad. I should be. So this is actually a class, right? Very basic error. Okay, now you can see client has printed received something. So actually it has printed received message which is returned by server. And let's look at server. So server is still running and it has got request parameter as hi from client. So this message we sent from client, it has been received by server, acknowledged by server. Here we printed and it has returned back to return back with this thing. So now so this is about simple request response, right? Now we are going to go ahead and create bidirectional implementation. So let me stop this. Okay, I'm going to create new proto buffer, new file that is bidirectional proto. Okay, and again for time being, what I'm going to do is I'm going to copy paste this. Okay, here the package is going to be bidirectional. Then I'm going to copy paste here bidirectional. Now, what is bidirectional? So here, instead of single request and response, we need stream. Okay. So let's look at the example and then we will come to know. No other changes. So now let's create. What I'm going to do is I'm going to create. Let's create new client. Client name is bidirectional client. Or first we need server. Okay. So similar to what we have seen for unary server, I'm going to actually copy everything here. So here only changes that but before that, let's go to terminal. And what we are going to do is here, I'm going to run this command again to create bidirectional proto so that it will create just like this pb2 and pb2 gRPC. We need a bidirectional implementation file for Python, right? So now you will see I have executed this command and we should see some typo. Okay, let's rename this as okay. Okay, now these two files are created and now we can start implementing this server. So what we are going to do is, so in main, so first of all, let's implement this service. This is bidirectional service. So we have to implement this. Okay, so here now it's important that I am going to delete this and I'm going to implement. Yeah, so here you can see now we have request iterator. Okay, so this is actually iterator. For each request in request iterator, what we need to do is we will print request parameter. So it's going to be same like this. Okay, we are just printing request.message, which is in our payload, and we should be now, rather than returning something, we are going to use yield here, and that yield should be returning this payload. Okay, and this is actually again it's going to be bidirectional. Okay, that's the reason I told you that. Remember, this is not return keyword. Okay. Yes, so we need to add, and here we need to add service as bidirectional service, and rest of things looks okay to me. Okay, so our server looks okay. Now let's create client. And here again, I'm going to copy paste everything. And first we are going to change bidirectional gRPC. All right. The client is going to be bidirectional. Okay. So we have now bidirectional client and we have multiple messages, right? So how we are going to create multiple message? We need multiple messages, right? So this is stub part is going to be same. The host, server, port, channel. We are going to subscribe, correct? This is not unary sub. This is bidirectional stub. Okay, channel. These things are same. Yeah. So here I'm going to create one method out here that is generate message, and this message is actually going to create some message for me, or rather let's run the loop. Let's create 5 messages. So here what I'm going to do is I'm going to yield a message. The message is going to look like this one, request payload. Let's pass this integer I here. Okay, so this generate message we are going to use. Let's not pass this parameter here. Yeah, so here we will use generate message, and we'll return response. And here again for response, we should get ideally multiple responses. And from that, what we'll do is we'll again iterate. All right, so let's try to run this and see we have implemented this incorrect. So server started without any issues. Now let's try to run client. Okay, so received 5 times from client, but let's look at server. So in server, you can see message number 0, 1, 2, 3, 4. Everything looks perfect. Now, what if I want to create, let's say I want to create client, one more implementation here with client streaming message. Okay, so here only basically client messages, client only streams the message. Okay, so I will create this in bidirectional. Okay, so let me create one more method, that client streaming message. So here client is going to stream its request payload. Okay, but in return server is not expecting, server is not supposed to send a payload. Okay, this is one implementation, and another is server streaming. So this is half duplex. Okay, not the complete duplex, bidirectional. So here request payload is not streaming, but server is actually streaming the message. Now let's look at how to implement these two things together. Okay, let me go to Python. Let's create protobuf command. Let's create new implementation. So remember, if you have done any changes in this proto file, then you need to rerun this command so that those changes will reflect in this bidirectional file. Now here, let's make some changes here in server side. So first is, let's implement client streaming message. So we have iterator, correct? No problem receiving this request from the iterator. But the difference is here we need to return. Okay, so very important step here. So we are going to, instead of yield, what we are going to do is we are going to return from here this message, and the another implementation is where server streaming message, where we need, when we get a request like, so this is like a unary server handling will print. So like this, we will print the request of message, but in the response, what we do is, so again, we'll write a loop. So let's say 5. And we will create a response payload. Rather, let's yield all right. So here we are supposed to use yield, correct? It's fine. Okay. Now here, what happens is after completion, we'll return just single response. So this should be out of this loop. Okay. So server side looks okay to me. So we implemented a client streaming message, server streaming message. Now let's go to client part. So here now we have part 1 is okay. So second part is, let me implement client streaming, correct? So for client streaming message, what do we need is, okay, same thing. Sorry. So we actually need same thing here. And yeah. So it's from client side we request, but we return single payload. Okay. So inside this, I'm going to just copy paste because this is not going to change. But here let's client streaming response. We expect only one response in case of client streaming message. Okay. So let's print this. So we don't need here loop now because response is not streaming, correct? So this is how we print. And last part is server streaming. That is, server is client is going to request single request, but in response we get a loop, right? So this is actually going to be like this. So let's write it down. Server streaming response, get server stream message. Okay, now let's create this method. Server stream message. Oh, here we forgot server stream message. And this, we need just one request, right? So I'm going to okay, so this is a single message, correct? All right, let's run this. So first run server. Server is running. Let's run client. Okay, so there is one problem. And let's look at where. So it's in the last part. So it says that unary string callable got an unexpected argument message. Oh, I got it. So here the message says that, so we actually we have to create request payload, right? So yeah, we have to create request payload here, and then that we have to pass, right? So this, let's create request payload because our contract says that it's not a string message, right? It's a request. Yeah, now it should work.
Oh, so just rename these responses to server streaming response and you will see server's response here. Let's run the server again. Here we go. So here is a reply from server. So server returns this for loop. In this for loop, this yield. So this is a streaming from server to client. So this is server streaming message.
So this is how 4 types of communications are possible. So full streaming, bidirectional, client streaming, server streaming, and traditional request response. So thanks for watching this video, and let me know your feedback through comments, and please like, share, subscribe if you are liking the content. So thanks for watching.